Boyle's law is constantly being applied in real life. One example is breathing. When we inhale, the chest expands, increasing lung volume and lowering air pressure. Therefore, air flows in. When we exhale, the chest contracts, decreasing volume and raising the pressure, pushing the air out. This cycle follows Boyle's law, which again says that as volume increases, pressure decreases. To demonstrate Boyle's law, I will need a bottle, a pin, and a balloon. First, I'll place the balloon inside the bottle and secure its opening around the bottle's mouth. Then, I'll puncture a small hole on the side of the bottle. As you can see, when I suck air out of the bottle, the balloon inflates. This happens because reducing the pressure inside the bottle allows the higher external pressure from the room to push air into the balloon, causing it to expand. Boyle's law states that as pressure decreases, volume increases, which explains why the balloon inflates when the air pressure inside the bottle drops.
For this experiment, you'll need a candle, a lighter, a cup of milk or water, and a bowl.
First, place the candle on the center of the bowl. It is important to make sure it is stable to ensure it doesn't fall off during the experiment. Next, pour water into the bowl. Now, light the candle. Then, take the glass and carefully place it upside down over the candle, trapping it inside. The candle will go out after a few seconds. As the candle burns, it heats the air inside the glass. But once it goes out, the air inside cools down and contracts. This causes the air pressure outside the glass to push the water up into the jar. The rising water happens because of the change in air pressure. This experiment shows how air pressure can push things, even water, without touching them by the help of Charles' law. A practical example of Charles' law is in hot air balloons. As the air inside the balloon is heated, it expands, causing the volume of the balloon to increase and making it rise due to the reduced density of the heated air inside compared to the cooler air outside.
The combined gas law combines Boyle's, Charles, and Gay-Lussac's law into one equation. This equation describes the relationship between pressure, volume, and temperature when the amount of gas remains constant. In simple terms, the combined gas law explains how gases behave when they undergo changes in multiple conditions at the same time. It shows that if one factor, pressure, volume, or temperature, changes, it will affect the others accordingly. A common example in daily life is a deflating car in cold weather. As the temperature drops, the gas inside the tire contracts, reducing its volume and pressure. On the other hand, on a hot day, the air inside expands, increasing pressure and making the tire feel firmer. This law is useful in many real-world applications such as weather balloons, airplane cabin pressure adjustments, and the functioning of pressure cookers. For this experiment, you will need ice-cold water, tongs, a can, an empty can, and a source of fire. First, pour a small amount of water into the soda can. Next, heat the can on the stove until you can see steam coming out of the can. Lastly, quickly use the tongs to flip the hot can upside down into the bowl of ice-cold water. Now watch it collapse instantly. Heating the can increases the temperature and lowers the pressure inside as steam pushes out air. When suddenly cooled, the steam condenses, creating a pressure drop inside. The higher external atmospheric pressure crushes the can, demonstrating how temperature, volume, and pressure interact.
So the materials needed for this experiment are an empty soda can, a heat source, tongs, a bowl of cold water, and a pan. First, let's heat the air inside the can. I'm placing the empty soda can directly on the heated pan. According to Gay-Lussac's law, when temperature increases, pressure also increases, as long as the volume stays the same. As the air inside gets hotter, the gas molecules move faster, increasing their pressure. So while we are waiting for the can to heat up, let's pour the cold water to the bowl. Now, using tongs, quickly place the can upside down into this bowl of cold water, sealing the opening. As the can enters the water rushes in or the pressure shifts inside. Since the external atmospheric pressure is higher, it forces water into the can to equalize the pressure difference. This experiment can be relayed or be used in practical application. An example of this is aerosol cans. Spray cans like deodorants or hairspray are pressurized inside. When exposed to heat, the temperature rises, increasing the pressure inside. If it gets too high, the can may explode. So at the end, the volume stays constant and both temperature and pressure increases as said in Gay-Lussac's law.
The ideal gas law is also used in real life. One example is meteorologists use the ideal gas law to model atmospheric behavior by calculating changes in air pressure, temperature, and volume at different altitude, allowing them to predict weather patterns by understanding how air masses rise, sink, and move based on these variables. Essentially, the law helps them analyze how air parcels behave as they move through the atmosphere and considering factors like temperature and pressure changes with altitude. In demonstrating ideal gas law, you need a bottle, straw, and the water. First step, you need to put the straw in a bottle. After you put the straw in a bottle, you need to put the bottle with the straw in a water. And using your two hands, hold the bottle, and you will see a bubbles. The reason why there's a bubbles because the temperature of the bottle is getting hot because of the hand, and if the temperature is increasing, the pressure is also increasing too.